Let us begin application sum of circle. So we have first sum as in the given figure P is the center of a circle. So here is a circle with center P. Then we have chord AB and CD intersect on diameter at E. So diameter we got it, and the chords are AB and CD which are intersecting at point E. If angle AEP, you can see angle AEP is congruent to angle DEP they have given, then prove that chord AB congruent to chord CD. We have to do construction. For that, draw a perpendicular from center P to chord AB and CD, which intersect chord AB at F and CD at G. Now we're going to prove the two triangles congruent. I hope we remember we have learned that when the two chords of a circle are equidistant from the center, they are congruent. The same property we'll use. For that we are trying to prove GP congruent to PE. So we are taking triangle PFE and triangle PGE. In that we have first point as angle AEP congruent to angle DEP, which is given to us. But AEP is not a part of a triangle what we have taken. Similarly, DEP is also not a part of the triangle. So to make it a part of a triangle, we will write same angle with FEP, angle FEP congruent to angle GEP. Why we can write so? Because point EFA are collinear. So it means AEP angle can be written as FEP also. Similarly, DEP can be written as GEP also. Second point, angle PFE congruent to angle PGE, which is right angle. That is due to construction we have drawn perpendicular. It means it is right angle. So both the angles measure 90 degree. Third point, segment PE is congruent to segment PE because they are common in both the triangles. I know you will think it is hypotenuse also, so you can write down hypo also, there is no issue. Now we have got 3 points, we will get the triangles congruent. Triangle PFE congruent to triangle PGE by SAA test, or you can say AAS test also. So we have got the two triangles congruent. Once the two triangles are congruent, the remaining corresponding parts are also congruent. But we required GP and PF, so we got it here. Segment PF congruent to segment PG, corresponding sides of congruent triangle. Now we have got the chords equidistant, therefore we can say chord AB congruent to chord CD. The reason will be in a circle, chords equidistant from the centers are congruent. Hence, proved that AB is equals to CD. Let us go for the next sum. We have the given figure in that CD is the diameter and the center O is a center of the circle. CD is perpendicular to chord AB at E. So here AB we have, and E is the point of intersection of chord AB and diameter CD, which is perpendicular. So we had put the mark of 90 degree. Show that triangle ABC is an isosceles triangle. So here is the triangle. Let us prove it here. As you know, CD is perpendicular to chord AB, which is given to us. Therefore, we can also say that OE is perpendicular to chord AB because C dash O dash E, these are collinear points, and O is the center of the circle. So OE is perpendicular to AB, and you know that perpendicular drawn from a center of a circle to its chord bisect the chord. Therefore, we get seg AE congruent to seg BE, which we indicate by identical sign. Now, what this shows that CD, which is a diameter, is perpendicular bisector of chord AB. Now it has become perpendicular bisector. Previously it was only perpendicular. So we have written from 1 and 2. Now you know perpendicular bisector theorem, what it is. Any point lying on the perpendicular bisector of a segment are equidistant from its end point. That means AC will be equals to CB because point C is lying on perpendicular bisector of AB. Which is the perpendicular bisector of AB? Diameter CD. Therefore, we get AC congruent to BC. This is the reason what I said. So we got AC congruent to BC. Now triangle CAB if you take and the two sides are equal, what do we call such triangle as? Isosceles triangle. Therefore, triangle ABC is an isosceles triangle by definition. See you in the next video.